because this is something I've been wondering about, studying, philosophizing about for a while. Ed, what are you? Oh, the symbol. It's just old Viking jewelry that has been found unearthed, and they make replicas of them in Scandinavia. So they're from, you know, that we've had like 5 different snakes on the cups and conference paraphernalia. So there's different ones for each conference. And this has to do with wisdom and all sorts of godly interventions. It's symbolism from very early on. But the snake is basically wisdom. So I think it suits this audience well. I don't know if we are going to go to hammers next or or ships perhaps, but I'll think about that. Okay, so what is the purpose of this talk? It's actually to show you that APL is still competitive for modern software projects, that we can continue to have fun, and that you can continue to make a case for APL in good faith. So what I'm going to talk a bit about is what the competition is up to and the challenges that modern software projects face. Something about complexity. And I'll talk a bit about Agile methodologies and then come back to why APL is such a good proposition. So what about the competition? They are improving, and they measure that. The Standish report is an annual report, and this is the 2000 report. So you can see, well, at least what they say is that they are improving over time. I think it looks a little bit coincidental whether it goes up or down, but this year in particular it's down a bit. So they have, and I should say here, success is actually a software project that finished on time, within budget, and delivered the promised value to the business. So they doubled from 16 to 30% successes. Not bad. The failed project was down from 28 to 24. And challenge projects, there are projects that eventually finish and deliver something. Maybe not the full thing, and certainly not on time, and vastly over budget, but it seems like they are going to finish. So that's the 45%. Okay, that was 2000, so I'm cheating, right? It's got to be better now. They are on an improving slope. No, they're not. It's even worse. Not worse, but exactly the same. There were a year in between where it was really high up, and everybody was raving about these numbers, but now, surprise, surprise, they're down again. Okay. So I looked at that because I wanted some statistics for how our the software industry doing. Are we starting to become obsolete because everybody else is getting very much better than they used to be? So I looked, the internet is a wonderful thing. You can find all sorts of research reports and stuff. You can get the academic papers straight to your computer, and that's a real benefit. So the British Royal Academy of Engineering has done this huge study why software projects fail. And they've come up with some reasons why they think it's a difficult thing to make software. Lack of constraints, it's what a project is all in the mind of the beholder. And because they don't know how to manifest software, they don't have, like everybody has sort of a sense of physical laws, so they don't think of Well, sometimes they do, but to get from Paris to London, they wouldn't build a spacecraft. Probably have a train or something like that. But with software, they can think everything, and they do, and they tell you to make it. Software is invisible. You ask for a piece of software to do something for the business, and until it's actually delivered, it's totally invisible. You can't get a feeling for what it's going to look like, when it's going to be ready. It's like a big bang. It wasn't there, now it's there. It's flexible, so in people's mind it can do everything, so they try to use it to do everything. It's usually not meant to do that, so it breaks. And there's the complexity because it takes a lot of people to create software. Pretty much none of them have any overview of what this whole project is. They are working with a microscope, studying the elephant, looking at a hair or piece of the trunk, so they lose track of where we're heading. They can't coordinate between them because none of them has an overview of what's going on. There's the uncertainty. The guy who wants the software knows exactly what he thinks he's asking for, except when he asks, somebody else's context catches in and put these words in his own context, which he then analyzes and gives on to some design person who, with his context or her context, then designs the software. So, I mean, this whole thing mutates all the way to implementation. And then there's a thing about the software that really the issue is not the software, it's the problem it's trying to solve. And the software is only part of that. The rest has to do with the organization within which it has to exist and provide the benefits. And very often, once the software is there, the management level who ordered it had forgotten all about it and actually don't put the tools in to change the organization the way it has to adapt to the software change that's provided. So, yeah. So these challenges were what they found. And what do they recommend? Best practices, more plans, tick lists, education, certification. Obviously, that's going to do it, because it can't be the engineering paradigm that's the problem, can it? I mean, these are the Royal Engineering Academy. They know that engineering is good also for software. So I looked a bit more on, there are also research reports on why do developers think that software is failing. And here's a list of all of them, and there's quite a lot of them, so I tried to sort them a bit. The blue one here all has to do with communication in a large organization and the way the politics of organizations influence projects like this. The green ones are, well, in my opinion, to do with how requirements are specified and why once they filter down to the implementers, they don't match any reality that they think is belonging to the real world. And then finally, the last four ones has to do with software development methodology. That's where our profession kicks in. So they can't keep the timetable. Many projects have lots of little mistakes, and none of these little mistakes are actually important enough to push the project. But then eventually you'll suffer the death by ants, because enough of these little things actually tilts the whole project and delays it a lot. And there's things to do with testing and having to use software you haven't been trained for. And then there's this complexity underestimated. And remember this thing about the 50 people of which only one have an overview, if you're lucky. So all the rest of the guys are just milling around. Okay, so in summary, the challenges to software projects have to do with communication. All the different levels of communication goes wrong. And I have a theory that all the methodologies, the older ones, have been created because of two things. Because people can't talk to each other because of different cultural contexts. When they have to write it down, it gets even worse. And the second thing is the lack of visualization, because an organization can't control how far a project has gone. So they make all these huge reports, piles of documentation, tons of tick lists, to just fill a communications and lack of visualization gap. And that's all it's doing. It has nothing to do with software development. And complexity. So that's interesting. I think, what is complexity? How do they define it actually? So I made a search for complexity, and I came across a quite wonderful group of people who, this is an organization, and they have a report called A Search for a Simpler Way, where they look at complexity in large organizations. And they also pointed to the industries where that is really a growing problem. And that's healthcare, pharmaceuticals, services, and banking and financial services. And guess where our customers are? Okay. So according to this study, the plan is ground zero for complexity, because believe it or not, an organization thinks if they make a plan, it is just going to magically materialize itself. By the management having authorized the plan, it's going to happen. No, it's not going to happen. What an organization can do, it can measure its business, it can control its money, it can control its purchases and its products, but it cannot control the decisions that the workforce have to make every day to get things done. And if they are not providing tools for the workforce to implement the plan, it's not going to happen. They identified three sources of complexity. It's integration of change. It's what I spoke about before. If you make a piece of software to support an organizational change, and these are sort of asynchronous in time. They start off, great kicks off and everything, software project. By the time the software is ready, the organization has mutated like 3 times in between and are not ready to accept the change in the form of the software. Because the management do not follow the progress of the plan. There are unclear goals and objectives, and it's how we communicate. And there's some nice examples, so I just took them for you. And this one, I think, is particularly important to our understanding of the topic of this talk. So the ability to bring together in one place, at one time, all the information necessary for one person to make a decision that will lead to success. There's unclear goals. Again, the thing about communicate objectives, but no tools to implement. Have a common focus with clear goals and a measurable outcome. Not just, we want to be the best supplier of nursery care in the world. So yeah, and How are we going to do that? And what do I get to make that happen? So, and then there's the communication in large corporations. I think this is hilarious. It's the messages that don't require any action, and there's no consequence if you don't act. And it's called, for your information, junk or spam. No, it's like you have these management seminars and they all get together and discuss values and how are we going to do this and strategy, and then they send out a lot of these for your information mails, but they don't put in place a plan that'll work. But they think it's going to happen just by itself. It doesn't. Okay. So, apparently these large corporations and the way they work have the same kind of problems as software development, I think. They also have the same project management models. And they also have the basic assumption that once you made a plan, it'll work. There's a bunch of people, and Dave Thomas, who were here earlier this week, were one of the founding members of the Agile consortium, who finally said, we can't make software with all these constraints. If it's software we're going to make, we have to look at what makes good software. So they came up with a manifest, and it's not an anti-methodology thing. It's like, get rid of all the crap that doesn't work for us, and let's focus on what works, and put that at the center of how we work with software. But did you know, just the other day, Stephen Taylor sent us a link. Tom DeMarco has denounced his total quality management. Do you remember back in the 80s, they were preaching to us every day and in every way how software engineering was just going to save the day? He's just announced it. I put the link into the slide so you can follow it and verify for yourself. He says it doesn't work with all this measurement. It's costly and it's putting constraints on the project. Okay, so the Agile Alliance, see, it's important that individuals and interactions between individuals are put at the center, not the processes and tools and tick lists and stuff, because it's the individuals who are going to produce the software. Working software rather than tons of documentation, because you can actually see it. Collaboration with the customer instead of having a contract and fight them the rest of the way. And respond to change rather than stick to a plan that were mistaken in the first place. So XP, which Stephen has been presenting to our forums for a while, is one implementation of the Agile Manifest. And if you want to read about it, and it's like coming home actually, an easy read is Extreme Programming Explained by Ken Beck. It's about 10 years old now, but it's still very valid. So the rules of engagement in XP is that business people and developers work together directly, daily, throughout the project, so that the developer understands what the business needs. They don't have to go through 7 tiers of analysts and designers and documenters and approval at management level and change to the contract to get back down and be allowed to change a yes to a no. Highest priority is customer satisfaction. Deliver software frequently so that, people are very gifted at telling you what they don't like, not so good at explaining correctly or exactly, concisely what they want. But the instant you put it in front of their face, they tell you whether they like it or not. And it's like what Gary explained. You can easily see if they fell in love with what you made for them, or they just say, this is going to make my life difficult. So, short circle deliveries, and the working software is the primary measure of progress. Global awareness, so the team work together in a way where they share the knowledge, share the understanding of where they're going, and there's a lot of storytelling in this methodology where the user writes the use cases, and that's what the developers are coding to, a real story from real life. And the team have to be able to honestly communicate with each other. Do you remember the list of the what developers said were the main failure reasons for software projects? Fear culture. So honest communication, I don't know if that's so much a problem in Denmark, but I think some places it is. Okay, so that brings us to APL's unique benefits. I mean, the Agile principles are extremely familiar to the way we've always worked, closely with the customer. Sometimes even the customer, particularly if they have a good set of utilities, are the programmer himself. The domain expert makes the programs. So we have the perfect pair that Dave Thomas referred to. And we have much better expressive power. We don't have to study the computer as much as other guys. And that's a quote I got from Bob Smith, who got it from somewhere else at the English Computer Association, the APL Association's conference in the spring. It's the thing that to solve a very simple problem, you have to study the computer. With APL, you don't have to study the computer, you study the problem and you solve it. And the user is also the programmer is the domain expert. We know how to develop frameworks where domain-specific notation can be used by the end user to explain their complex task to the computer. So we don't necessarily need to know all of the nitty-gritty details of his task, as long as we can provide them with a language where they can specify the actions that the computer have to make them happy. And this, I think, is also a key insight. We know how to bring together all that we know in one place at one time. And that's the prerequisite to take a decision that leads to a success. Our teams are small, shortening communication chains. The biggest team that I know of is a 100+ group. This is a different cut on the first bar chart thing you saw, the Standish group. This guy, Humphrey, has filtered it so that it's the size of the project up that axis, and it's measured in $1 million. And the success rate out this axis. So you can see that the more expensive it is, the less chance you have for it to work. And I maintain that most APL projects are around here, some up here. We can get not the complexity of the solution down, but the complexity of the corporation, the work to do the software. We can bring that down to very small teams, very good communication, direct feedback from the customer, so we always know where we're heading. Prototyping, we've always done that, immediately showing people what we thought they were saying. All these challenges we are naturally dealing with, we just haven't realized that that's what we're doing. So the selling proposition is this: APL projects don't fail. And if you know of APL projects that have failed, I would like to know about it, because I've asked around a lot and nobody has given me one, except I think Graham Robertson had a failed project. It was delivered, it did what it was supposed to do, but it was too cheap, so it got kicked out by one of the usual suspects. Because they wanted to sell $1 million project. As you know, would never. But more than $10 million for a project, there's a 0% chance for success. Some of them will eventually deliver something, not what you asked for. It'll be vastly more expensive than you thought, and it will be delayed. But it will. Isn't that interesting? So this is it. You can go and sell APL as the tool to make software projects that doesn't fail. That's what I wanted to say.